So we're back at the machine learning algorithm Visual Explorer, looking at K-means clustering. And we're going to go through the interactive demonstration to get a little bit better understanding of how our data can be sorted into categories without any labels. So K-means finds natural groupings in data by iteratively assigning points to the nearest centroid or cluster center and recomputing centroids. Click the canvas to add data points, choose K, then run the algorithm. So I'll start with something fairly obvious, and you can play around this as you like. So I'm going to put a cluster there, and a cluster there. Right. So this is kind of I'm definitely setting up a kind of a three clustered system. But imagine that we're looking at two variables, two different data sets to consider, and we can set them up on these axes, right? This two-dimensional plane. And we could think of things like, store square footage and revenue, right? And so that would be a very easy way to plot these points. And it might turn out like this. I have no idea. But in this case, I'm going to say the number of clusters, start with K equals 3. I've got 3, right? And then use the elbow method to find the best value. And so we're talking about inertia and silhouette, and we'll talk about how to do that. But I've got 43 points. Looks like they're separated here. Initialization, we'll do random at first because that's how it was outlined. We'll do random. And I'm not going to load a data set because I made my own. And so I'm going to run this. And so right off the bat, it gets this effort, right? The silhouette's 0.773. And so that's significantly higher than 0.5. I can try running it to 4 and then see what happens there. And we can run this again. And we see where the silhouette gets below 0.5, right? We're getting this run together. And so this is the idea that we're not getting a very good position. So we move back. Let's go to 2. Let's see what 2 does. I run this. Actually, the silhouette's doing a very good job here, so that's probably not the best example of that, but 3 is a little bit better, right? And so we can step over and over and over again and see if the iteration gets better and better and better, but they got it pretty quick, right? It didn't take very many iterations to figure out that these are kind of the clusters. So let's look at a different set, right? So it did a good job of labeling. This is group 1, this is cluster 2, this is cluster 3, and these white circles are the centroids. So these are where the best positions will be. Let's see if I can reset this. I don't think I set up a reset. So I can. Here we go. Okay, so let's try this again. We're going to pick a data set, store performance here. So this is also another setup for 3, right? And we'll run this once, and it took 50 iterations to get to very clear centroids of these 3 groups. But let's pick a more interesting starting point. That's not good. There we go. Let's pick a different, more interesting data point. Let's say a hard case, right? So we have a lot of clustered together. Maybe there is not even a very good way to cluster this, and so we'll drop down to maybe 2. Okay, and we'll see how this works. So we're picking here. We've got a silhouette of 0.396, so that's below 5, and so that's not a very good situation here. We want that above 0.5, and no matter what I do, these centroids aren't moving, and I'm not getting above this. So we're getting significant overlap. That doesn't mean it's meaningless. It might still be useful. You could go back to your data set and find these intermediary points and potentially remove them and say, no, I want to clear a separation, so at least I can target the most extreme cases, right? So there's ways that you can deal with K-means clustering to get something that you would like. So let's pick another one. Um, Again, we can run this as 3 and run it again. And again, in 50 iterations, it's getting to a good position where we're over 0.5. It's got high inertia. We can look at this visually and we can see how this is doing well. And you can, add your own data points if you like and run it again and see how that changes the model, how that changes the silhouette. But this is a good kind of effort to put forward. Here at K3, right, this is right in the middle. This is where we're trying to get to. If we get to K4, we're getting these very, very diminutive these diminutive numbers right here. So we're dropping down on silhouettes, and that's not where we want to be.